Welcome to the Deep Dive. So you're joining us today as we kind of take a look at some really amazing astronomical observatories around the globe. We know you like getting it to speed fast, getting the key info.
Exactly. Forget wading through tons of text. We've done that bit.
Yep. And we're focusing on, well, this article listing the 10 best observatories in the world.
Right. That's our jumping off point. But our mission today isn't just, reading a list.
Yeah.
We want to really dig into why these places are special, their locations, the tech, some surprising stuff in here.
Okay, sounds good. So where do we start? Let's head to Hawaii first.
Mauna Kea.
Yeah, Mauna Kea Observatory, MKO.
Mm-hmm.
It's right up on the summit. And the key thing here, maybe the most striking thing, is it's got the world's biggest collection of gear in one spot.
Collection. So
Yeah.
not just one giant telescope.
No. It's optical, infrared, submillimeter, a whole suite of instruments. More telescopes, actually, than any other single mountain peak observatory anywhere.
Huh. Why cram them all together like that? Well, it means astronomers can look at the same thing using different kinds of light, basically all at once. You get a much fuller picture, Different phenomena shine brightest in different wavelengths.
Okay. A multi-tool approach to the universe.
Got it. All right, from that hub, where next? You mentioned the VLT earlier. Chile.
Exactly. The very large telescope down in the Atacama Desert in northern Chile, operated by the European Southern Observatory, ESO.
Another high-altitude spot, right? That desert's famous for being dry.
Super dry.
Yeah.
And high. Cerro perfect conditions, really, which is critical for ground-based stuff. But the very large part, that's interesting, too.
How so?
It's actually 4 main telescopes, big ones. And they can work on their own or, and this is the clever bit, they can combine their light.
Combine it, like focus it all together.
Essentially, yes.
Uh-huh.
It gives them incredibly high angular resolution. Think super sharp images.
So they can see finer details on distant objects.
Precisely. Things that would just look fuzzy otherwise.
Yeah.
It highlights that international collaboration aspect, too. Okay, smart design. Now, somewhere completely different you mentioned. Antarctica. The South Pole Telescope.
Yeah, the SPT. Talk about extreme locations. It's right at the Emerson Scott South Pole Station.
Wow. Must be challenging to operate there.
Definitely. But the payoff is huge. It's a 10-meter dish, started work around early 2007. The South Pole offers this incredibly stable, incredibly dry atmosphere, perfect for certain wavelengths,
Like what, specifically?
especially things like the cosmic microwave background, that faint heat left over from the Big Bang. You need conditions like the South Pole gives you to study it properly.
Right, pushing the limits of where we can even do astronomy. Amazing. Okay, let's switch gears a bit. Back to the U.S., but more historical, Yerkes Observatory.
That's the one.
Oh.
In Wisconsin, often called the birthplace of modern astrophysics, which is quite a claim.
It really is. Does it look space age?
Not at all, actually.
Yeah.
That's the interesting contrast. It was founded way back in 1897. Yeah, so it doesn't have that sleek, modern look. It's in Williams Bay, Wisconsin, only about 150 feet altitude, much lower than the others we've talked about.
So why is it so important then?
Because it was foundational. It really pioneered the methods of astrophysics. The work done there set the stage for, well, pretty much everything that followed. It shows amazing science doesn't always need the newest kit.
A real cornerstone. Okay, let's head back up high then. Roca de los Muchachos in Spain's Canary Islands.
Right, the ORM. Back to high altitude, nearly 2,400 meters up. Excellent seeing conditions again. Great for optical and infrared in the northern hemisphere.
And what's its claim to fame? Another collection.
Actually, no, this one's different. It's home to the world's largest single aperture optical telescope.
So one massive mirror, unlike the VLT combining 4.
Exactly, just one huge primary mirror collecting as much light as possible. Different strategy, same goal, seeing farther, clearer.
Makes sense. Okay, from a giant eye to fire. A giant ear. Arecibo in Puerto Rico. The radio telescope.
Ugh, Arecibo. Iconic, absolutely. That massive 1,000-foot dish, completed in '63, one of the biggest single dishes ever built.
It was famous for SETI, right?
Yeah.
Searching for aliens.
It definitely captured the public imagination with SETI, yeah. But it did so much more. Radio astronomy, obviously, listening to faint signals from space, but also aeronomy, studying our own upper atmosphere.
Really?
And radar astronomy, too, bouncing signals off planets, asteroids to map them. Incredibly versatile. Cornell University managed it for a long time. A real landmark.
A multitasking giant then. Cool. Okay, let's hop hemispheres. Australia, the Australian Astronomical Observatory.
Yep, the AAO, over in Coonabarabran, New South Wales, up at about 1,164 meters, vital for covering the southern sky.
And what's the setup there?
They run two main telescopes, the 3.9-meter Anglo-Australian telescope, the AAT, and the smaller 1.2-meter UK Schmidt telescope.
Different sizes, different jobs.
Exactly. The big one, the AAT, is for deep dives on specific targets. The Schmidt is like a wide-angle lens designed for surveying huge patches of sky quickly. They complement each other.
Covering all the bases.
Mhm.
Nice. Oh, we seem to be heading back to Chile.
Yeah.
Clearly the place to be for astronomy.
It really is an incredible location. First up, back in the Atacama, there's the University of Tokyo Atacama Observatory, or TAO.
Okay, what makes TAO stand out in such a crowded neighborhood?
Altitude. Extreme altitude. It's on the summit of Cerro Chajnantor at 5,640 meters. That's incredibly high.
Whoa, highest in the world.
Yep, holds the record for the highest astronomical observatory on the planet.
Must be tough to work there. Why go that high?
It gets you above even more of the Earth's atmosphere, especially the water vapor. This opens up specific infrared wavelengths that are just totally blocked lower down. It's about accessing parts of the spectrum you just can't see otherwise. Worth the challenge.
Pushing the altitude barrier.
Mm.
Incredible. And close by, also in the Atacama, ALMA. Sounds big.
ALMA is huge. The Atacama Large Millimeter Submillimeter Array. If you think about the scale of modern astronomy, ALMA is kind of the peak right now.
Is it one telescope? Or like the VLT?
More like the VLT, but for radio waves. It's an array of 66 separate radio telescopes, big 12-meter ones and smaller 7-meter ones, all working together as one giant instrument.
66. Wow. Who runs that?
It's this massive international project. Europe, the US, Canada, East Asia, Chile, everyone pooling resources. And it shows in the cost over $1 billion. The most expensive ground-based telescope running today.
$1 billion. What do you get for that? What kind of science?
ALMA observes in millimeter and submillimeter wavelengths. That's perfect for peering into those really dense, cold clouds of gas and dust where stars and planets are actually being born, stuff that's invisible in normal light.
So it sees the very beginning of stars and planets.
Exactly. It lets us witness cosmic construction zones, a truly groundbreaking facility.
Amazing. Okay, one more on the list. The Indian Astronomical Observatory.
That's right, the IAO, also very high up, 4,500 meters. So again, tapping into those benefits of altitude.
Where in India is it?
It's operated by the Indian Institute of Astrophysics in Bangalore. It just further shows how global this effort has become, putting these advanced facilities in the best possible locations worldwide. It ranks among the highest observatories globally.
So a really diverse tour.
Mm-hmm.
From Hawaii's peaks, Chile's deserts, the South Pole, even historic Wisconsin. It's quite a range of places and technologies.
It really is. You go from Yerkes, the literal birthplace of modern astrophysics, laying the groundwork,
Right.
all the way to something like ALMA, this huge international collaboration pushing the absolute cutting edge to see how stars form, or Arecibo listening for, well, who knows what.
Each one adding a different piece to the puzzle.
Exactly. They all represent this incredible human drive, this curiosity to understand the universe and our place in it, the investment, the ingenuity. It's pretty remarkable.
It really makes you think. Okay, so reflecting on all this incredible effort, all these amazing sites, here's something for you, our listener, to ponder. Considering everything we've talked about, the money, the technology, the sheer human dedication, what single discovery, maybe from one of these places, do you think would most fundamentally change how humanity sees itself in the cosmos?
That's a deep one.
Definitely something to keep looking up for. Thanks for joining us on this deep dive.